Power has one of the most diverse generation mixes in North America. We have nuclear and hydro, thermal, and now of course wind.
Kent Hills Wind Farm started planning around 2003. It's a 32 turbine site. It's 96 megawatts.
There's about 26 kilometers of roads that link all the different turbines, which are set up in different rows to capture the wind and get the right wind direction that comes off that direction from the Bay of Fundy.
Kent Hills is a great location. It has a great wind resource. It has a large parcel of land on which to build a wind farm on, and it's far enough away from all the residential areas that we don't interfere with any of their enjoyment. And it's just basically an ideal location to build a wind farm.
Each of the turbines produces electricity at its site, and it's collected through a collection system that brings it to a central substation.
The Kent Hills project is roughly 155 structures, 28.5 kilometers. So this is basically our pole crew. Right now we're setting poles on the Kent Hills end of the line. So we have a digger, two excavators, one for hammering the rock and one for digging the rock. And then the digger, we're using it to set the poles.
Like if we got a 65-foot pole, we go down 8.5 feet. 55 is like 7.5. It all depends what kind of ground you're in, sandstone or rock. It could be just like topsoil too, it's a lot easier to dig.
How many pole structures do you usually go through?
It just depends on the digging.
Yeah?
Yeah, if it's good digging, we get 5 or 6 structures up a day.
And that's a good day?
Yeah, that's usually a pretty good day.
Transportation of the towers began via rail into Moncton at the Gordon Hump Yard. They were then loaded onto trucks, transported out to the site at Prosserbrook, Kent Hills Wind Farm. So to tow the towers up the hill, we actually had to have a larger transport, 6-wheel drive transport truck tie onto the trailer. And due to the windy roads and the steep grade, it was kind of a different sight out here to see that kind of traffic on the little back roads in New Brunswick on top of the mountain. So the turbine begins with a concrete foundation. It's approximately 5 feet thick. It has about 65 cubic meters of concrete in it. It also has 18 rock anchors that extend down about 40 feet into the soil, and basically it's all rock up here. After that is complete, we have a crane come along, a small crawler crane. It's 230 tons. It erects the first 2 tower sections, which is followed by the larger, the 440-ton crane. It erects the next 2 tower sections, the nacelle and the hub, puts it to a total height of around 80 meters.
The nacelle is actually 75 ton, probably the most difficult lift just because of the surface area. It's like a big kite. So even though there's no wind down here, you go up 80 meters and you've got considerably much more wind. Depending on the direction the wind is coming and the face of the nacelle creates a problem. We've been doing this for many years, so we've gotten to figure out where the bugs are, and so the guys have a really good handle on it. From the time it leaves the ground, the time it gets to the top, you're looking at 10-12 minutes. It's not that long, it's the preparation that takes the time.
Just be aware of stuff going on, equipment moving, everything.
Anytime there's a critical lift like this, there's always a safety meeting where they gather all the guys together. So the guys up top, the guys down below, they all know what's going on. There's radio communication between the towers, the guys in the tower, the guys on the ground constantly, as well as obviously the crane operator has also got that one as well. There is quite a bit of prep that goes into this. You're seeing the kind of the culmination of a couple months worth of work.
So as soon as the large crane is done erecting the nacelle and the hub, the smaller 230-ton crane, it has an extended boom now. It comes along and it also puts the blades on. So the blades were all manufactured in Denmark. They're fiberglass blade, fiberglass laminated blade, and they were transported here on ships across the ocean, arrived in the port of St. John, unloaded there, and then every day there was one complete set of blades, which is 3 blades per turbine, were hauled from St. John up to the site at Kent Hills. And they were the longest load. They were